Hi, I'm Lance MacNevin, and I've known Michael Riddler and Grant Blackmore for about 15 years. When I first met Michael, I used to talk to him a lot about hydronic systems, radiant heating and outdoor snow melting, radiant cooling and things like that. And he was very interested. He was just a sponge for information, and he thought I was really smart and knew a lot. And then one day I started mentioning the names like Robert Bean and John Sigenthaler and Dan Houlihan. And then Michael did his own research and met those people and realized that a lot of what I knew about hydronics came from those gentlemen. So I'm glad to be in good company here as being part of Eden Energy's 40th anniversary. So my presentation is going to be on latest industry code updates and PPI tools and publications. So I am Lance MacNevin, and I'm the Director of Engineering for the Building and Construction Division of the Plastics Pipe Institute. I'll explain what that means in a second. I've been involved with the plastic piping industry since 1993, which is almost 30 years now, I guess. And I'm a bit of a pipe geek. In addition to having been involved with the development of piping systems and fitting systems over the years, I also get involved with a lot of codes and standards committees. So a list of some of those committees is shown here. So that's ASHRAE, ASTM, ASPE, AWWA, CSA, IAPMO, ICC, IGSHPA, NSF, and I also participate in other industry trade groups like the Hydronic Industry Alliance Commercial and the Radiant Professionals Alliance. My contact information is shown below here if anybody would like to get in touch with me for anything. The Plastics Pipe Institute, my employer, is a nonprofit trade association serving North America based down in Irving, Texas. But the organization officially began back in 1950, more than 70 years ago, in the early days of the plastic pipe industry when the pioneering engineers wanted to get together and collaborate and develop test methods for these new plastic piping systems. And eventually to write industry standards, such as those standards that we have today from ASTM and CSA. So the plastic pipe industry, it's not new. Even our association has been around for more than 70 years now. And today we have 5 divisions and 12 employees. Our mission is to advance the acceptance and use of plastic pipe systems through research, education, technical expertise, and advocacy. We're supported by our members. We have over 170 member firms from across North America and around the world who are involved with the plastic pipe industry here in North America. And our website is simply plasticpipe.org. So in particular, I work for the Building and Construction Division, which was the division formed more than 20 years ago to focus on plastic pressure pipe and tubing systems for plumbing and mechanical systems. So primarily what we're involved with is plumbing, water service, fire protection. Then on the hydronic side with radiant heating and cooling, snow and ice melting, district heating cooling, and ground source geothermal piping systems. The materials that we represent, and these are produced by our members, everything alphabetically from CPVC to high density polyethylene, PEX, PERT, PEX aluminum PEX, and polypropylene, of which there's 2 subtypes known as PPR and PPRCT. And to get to our website, you can just go to plasticpipe.org and select our division, or you can use the URL shown here. And the image on the bottom here is kind of a family picture of a lot of the different piping materials that we represent within the Building and Construction Division. So here's my brief presentation outline. First, I'm actually going to talk about 3 different CSA standards and codes. The first of these is B137 on thermoplastic pressure pipe systems. The next is on B214, the installation code for hydronic heating systems. And the third is CSA B214, which is the code for ground source heat pump systems. And then I'm going to talk a little bit about PPI tools and publications that we offer to the industry, and then touch on some PPI research projects which may be of interest. So the first of these is CSA B137. This is the collection of CSA standards for thermoplastic pressure pipe systems. These CSA standards first started developing and were first published in 1973, which is almost 50 years ago. And this collection of standards is revised about every 3 years. The current collection of standards that we're working with was published in the year 2020, and these standards are put together by a technical committee of volunteer members. Over 40 people make up this technical committee, and this committee has been working hard on the next edition, which is expected to publish about a year from now in 2023. These standards are really important because they define all the properties of plastic pressure pipe systems, and the National Plumbing Code of Canada and the National Building Code of Canada refer to B137 standards for piping products. The first of these standards is called B137.0. That's the one shown on the screen here, and that's the one that focuses on definitions and general requirements and methods of testing for all types of plastic pressure pipe systems. But then we get involved with 15 individual standards within the B137 family. And these standards apply to all different types of pressure pipe materials. The ones I'm showing here are the ones that relate to piping for plumbing and mechanical systems. So the first of these is B137.1, and that's the standard for polyethylene pipe, tubing, and fittings. And that pipe could be used for water applications or geothermal applications. Then comes B137.5, which is the standard for cross-linked polyethylene, or PEX, tubing systems. B137.6 is for CPVC, pipe, tubing, and fittings. B137.10 is for PEX, aluminum PEX, composite pressure pipe systems. B137.11 is for polypropylene, and that's PPR and PPRCT pipe and fittings. And then finally, B137.18 is for polyethylene of raised temperature, or PERT, tubing systems. So these standards are developed by the CSA Technical Committee. These standards are used by certification agencies when they're testing and certifying products to make sure that they're suitable for sale and third-party listings. And anybody can actually purchase these standards directly from CSA. You can buy them as PDF files that you can download. And in fact, all the standards that I'm showing here in the screen right now are considered the plumbing and mechanical standards, and they can be purchased as a bundle from CSA if you actually want to read what the real pipe requirements are for each of these different piping products. It's available. The next CSA standard I'm going to talk on is B214, which is the installation code for hydronic heating systems. Development on this standard started way back in the 1990s. And then the first edition of B214 was published in 2001. And then it's been updated approximately every 5 years since then. And CSA B214 has been part of the National Building Code. So it's been referenced in the National Building Code since 2010. So a few covers of different editions from over the years are shown here. The 2007 edition, then 5 years later in 2012. And then 4 years later, we had a 2016 edition. The current edition is from 2021, and this was released in January 2021, almost 2 years ago now, I guess. And this edition of B214 had a lot of updates. Not so much on the radiant heating side per se, but a lot of other updates related to safety and proper installation. So it includes minimum requirements and topics such as hydronic fluid and safety devices and flushing. That's in Section 4. Section 5 addresses heating appliances such as boilers and heat pumps. Section 6 is on circulators, sizing, location, and support. Section 9 is on hydronic piping and piping installation. That's main pipes themselves. Section 11 is on valves and manifolds. Section 12 is on controls. Section 14 is on radiant heating. This is where you find the requirements for maximum floor temperatures for different types of surface areas throughout a house or a building. Section 17 is on snow and ice melting. And this is where you'd find information about maximum circuit lengths, recommended maximum circuit lengths for snow and ice melting loops, and control requirements and things like that. So a lot of good content, very specific content, very relevant to the hydronic industry. It also has a section called Annex C on radiant cooling. It's not a requirement for radiant cooling, but it's 2 pages of really good condensed information on how radiant cooling systems work and how they should be controlled. And then one of the things that was new for 2021 is an inspection checklist for building officials. So if the building official is inspecting a radiant heating system, he or she should use this inspection checklist to make sure that they're capturing all the things that are inspectable and are important. And I'd recommend that any contractor use that inspection checklist for all your own projects as well, so that you catch everything before an inspector does. Here's an example of something new that was added in 2021. Before that edition, there was actually no requirements for manifolds in the code. But in the 2021 edition, there is a new clause, 11.3, all about manifolds. And it says, manifolds shall be capable of withstanding the pressure and temperature of the system. That's obvious. And be equipped with isolation valves on supply and return headers. Be manufactured of material that is compatible with the system fluid. Be sized according to the design flow rates. And be installed in accordance with the manufacturer's installation instructions. Really important content that was just never in B214 before this latest edition, but that just gives an example of the type of improvements and additions that were made to this newest edition. So we recommend that everybody get a copy and start implementing this as part of your own hydronic design and installations. The third CSA standard we're going to talk about here today is ANSI CSA B214 Design and installation of ground source heat pump systems for commercial and residential buildings. So there's different editions of C448 out there. The first edition was published way back in 2002, 20 years ago. It had a major update in 2013, and then another major update in the 2016 edition. And the 2016 edition was the first one that was considered a binational standard. So it actually has the ANSI added to the front of it. ANSI is the American National Standards Institute. So that means that the development of this standard met all the requirements of the United States as well as Canadian requirements for development of an industry consensus standard. So this latest edition was developed by a binational technical committee comprised of the industry's leaders from across Canada and the US. It's a very good code, very comprehensive, includes a lot of content, not just about the piping in the ground, but about the grouting, the pumping, the heat pumps themselves, and design and installation of lots of different types of geothermal systems. Because as we know, there's not just vertical systems and horizontal systems, there's also submerged systems and inclined or angled systems, lots of other different subtypes of installation types, and those are addressed within this standard. Now, the technical committee has been reformed and has been working hard for the last year and a half developing the next edition of C448, which is expected to publish about a year from now or sooner in 2023. And I should mention actually part of the title of C448, not just does it have ANSI at the front, it also has IGSHPA accreditation. So IGSHPA is the International Ground Source Heat Pump Association, and they were directly involved with the development of C448. From a staffing perspective all the way down, and IGSHPA also credits the content of C448. So their name is right on the title. All right, I'm going to shift gears a little bit and talk a little bit about some activities within our organization, the Plastics Pipe Institute. First thing I want to let everybody know is about the types of tools and publications that we have that we provide to the industry. So as a nonprofit trade association, PPI does not sell anything. We have one book for sale that you can buy as a paper copy, but otherwise all the information we have, it's free for public access on our website. And again, our work is supported by our member firms, over 170 firms that pay dues to PPI every year to support the work of staff and research projects that we do at outside laboratories so that we can be the voice of the industry and speak on behalf of the industry with a non-biased voice. So we invite you to go to our website anytime, every day if you like. Again, start by going to plasticpipe.org and then select the Building and Construction division. And here is a glimpse of some of the things that you will find there. First of all, we have material web pages. So for each of the piping materials that we represent, each of those materials has its own web page. So there's a web page all about polypropylene piping systems that talks about what the systems are, what their pressure ratings are, what dimensions and diameters are available, what standards apply. And in fact, there's actually a link to all the current relevant standards for that pipe on that webpage as well. And then the list of all the PPI member firms that produce polypropylene systems, those firms are also listed on the polypropylene page. So we have the same type of page for PEX and CPVC, high-density polyethylene pipes for geothermal applications, PEX, aluminum PEX, and PERT materials. So a lot of great information on those material web pages is available. We also have a web page called the Technical Literature or Technical Publications page, and this is where we post our own publications. And we generate 1 or 2 new publications each year, or we update old ones with the latest and newest information. So here's an example of 3 recent publications shown here from left to right. The one on the left is called Technical Notes 17, and that was PPI's first document, first written 20 years ago to introduce PEX tubing systems to North America. And it's been recently updated in 2021. So it's kind of your Bible, your handbook about PEX tubing systems. Download that for free. The next one shown here is on insulation recommendations for plastic pressure piping materials in residential applications. We get those questions a lot. Should we insulate pipes? And if so, how much? So that document addresses our recommendations there. And then the third one shown here is called Recommendation E, a recommendation against mixing hydronic heating water with potable water in so-called combined systems. So we invite you to read all about that as well. And that's just an example of some of many of our technical publications. And we're also always developing new ones. So here's a couple of examples of new ones that are in development. The one on the left is a new PPI model specification, and this one will be for plastic piping materials for ground source geothermal applications. So it'll be on behalf of the industry, all the right words in all the right places for an engineer or specifier that wants to specify the latest additions of HDPE or PEX or PERT tubing systems for ground loop, including the right fittings and installation requirements and things like that. And then the image on the right here, something we're developing, is a brand new ASTM standard practice for fusion of polypropylene piping systems. So there's a lot of polypropylene in use in North America today, and up till now there's no standard industry document to show people how to join those pipes and fittings via the heat fusion process or electrofusion or sidewall fusion. So this new document that's being developed by PPI members will then be submitted to the ASTM organization for balloting through their organization, and many PPI members are also part of ASTM. And eventually that will be published by the American Society for Testing and Materials, ASTM, as an ASTM document. And this type of document will be known as a standard practice. So that is in development. Both of these will probably be publishing in 2023. We have a contest known as the Project of the Year, where many of our members will submit a project at the beginning of each year, a project from the previous year that was just installed. And then we have a committee of members that actually judge and select winners for this Project of the Year award each year. And one of our web pages lists all the Project of the Year winners since the year 2010. We write a case study on each of them, lots of great photographs, and talk about why the products were selected and how they were used and what the benefits of that type of system was. So the most recent one shown here from 2021, one of the ones at the very top, was on a snow and ice melt system at a big overhead pedestrian bridge at Utah Valley University in Utah, a 970-foot long bridge that went over an interstate and train tracks, and it was powered up by a snow melt system, and the piping for that snow melt system came from both Rahau and Uponor, and that project was one of the winners for 2021. We do a lot of presentations, and a lot of our presentations are accredited by the American Society of Plumbing Engineers, or ASPE, which means that they're eligible for continuing education for engineers across North America. And once we develop those presentations, we often put a PDF copy of the slides on one of our web pages. PowerPoint presentations like this are a great way to share information with lots of images and photographs and things like that. So once we put those presentations together and give them to a conference, we normally post them to our website with good keywords so you can find them, and just make them publicly available so people can kind of read them and learn more on their own. We have another page of case studies. So in addition to the Project of the Year winners, we have another big collection of case studies. about plumbing and mechanical systems on a webpage that looks just like this. And then finally, I want to introduce everybody to our plastic pipe design calculator. Hopefully you've heard of it before, but if not, this is going to be a great tool for everybody here as part of this event. The plastic pipe design calculator from PPI was first launched in 2015, and it was developed for us by the Avenir software company out of Calgary, Alberta. That's the firm that also invented LoopCAD. But the calculator that they developed for PPI, which is free on our website, it has 5 different functions or 5 different calculations it can do so far. It does pressure and head loss calculations. And not just for PEX, as shown here. It does it for all the piping materials that we've talked about today, and it does it for hot water, cold water, or different types of antifreeze mixtures as well. And it can also be used for geothermal systems. So if you check the button at the top that says, is this a geothermal application? If you check yes, then you'll have access to all the geothermal pipes from a drop-down menu, and you can actually select methanol as a fluid choice if you're allowed to use methanol where you are as a fluid choice. The calculator also has functions for hydraulic shock, pipe weight and volume calculations, thermal expansion calculations, and expansion arm and loop design. And that's really important when we're talking about indoor piping because of the high thermal rates of expansion for many types of plastic pipe materials. You need to make sure you accommodate that through expansion arms or loops, and this calculator will help guide you. We're also developing a 6th function, which is going to be coming soon, possibly by the end of this year, and that's going to be to calculate static water column pressure. So whether it's vertical pipes in a high-rise building or pipes in a deep geothermal borehole, there's a lot of pressure in the pipes at the bottom of those vertical water pipes caused by the static water pressure of the water itself. And this new function will quickly be able to calculate that for you to make sure that you don't build piping systems that actually exceed the pressure ratings of the pipe itself. Nobody would want that to happen. So to access this calculator, you can get to it from the PPI webpage or go to plasticpipecalculator.com, and that will take you directly there. To let you know about a little bit of research activities that PPI is working on. We're always developing new research. One of the things we're doing is developing an official test method for pressure loss testing through pipes and fittings. Believe it or not, there is no official test method for doing that work. So we're pioneering that and through laboratory testing, trying to develop that test method over the next year or two. We're researching domestic hot water recirculation velocities in terms of what should be allowed in different piping materials. We're updating an AWWA standard called C904 for PEX water service line. That work is almost done. We're developing a new PPI document to address the buckling of plastic pipes in geothermal boreholes. And there will also be a PPI calculator to address that as well. We're going to develop a document about spray foam insulation and the potential dangers of using that around any type of plastic pipe material. And then we're always working on updating our industry standards. So you don't really hear about our research projects until they're done, but these are the things that PPI staff and our members are collaborating on every week. And then speaking of collaboration, we also do a lot of industry collaboration with other organizations and entities. And one of the most important of these is our collaboration with the International Ground Source Heat Pump Association, or IGSPA. As many of you know, IGSPA was kind of reformed, reinvented about 2 years ago now. Jeff Hammond is the executive director of the new IGSPA, and he's really rebuilding this organization with his leadership team through their board of directors. They're doing a fantastic job of this. So earlier this year, in 2022, PPI and IGSPA actually signed a memorandum of understanding, which is an agreement signed by the presidents of both organizations that talk about how we're going to collaborate on various tools and educational products and other things that we can do, collaborating and working together to greater support the geothermal industry. We realize that this is a really exciting time for growth in the geothermal industry, but it has to be done right, it has to be done responsibly, and there has to be good knowledge and training available to everybody who wants to participate in this industry. So IGSPA and PPI are collaborating, again, every week. We're working together to see what tools we can put together cooperatively to better support this industry. So we did a press release about the Memorandum of Understanding a couple of weeks ago, and grateful that our press release published in both Mechanical Business and HPAC Magazine. So with that brings me to the end of my presentation. Thanks for paying attention. And again, if anybody has any questions about anything I talked about here, feel free to reach out to me directly with my contact information shown below. Thanks very much. And thanks to Eden Energy for hosting me.